AI and ML in healthcare. Now, how exactly can we integrate artificial intelligence in healthcare? We shall see in our project. We chose human activity recognition as a idea. Now, what exactly is human activity recognition? It is basically identifying specific movements or actions of a person based on sensor data. Now, how do we obtain this sensor data? We all have mobile phones and smartphones, and these smartphones have embedded sensors in them, being the accelerometer, the gyroscope, the digital compasses, or the GPS, cameras, all of the above. Now, these sensors they have the ability to track the various positional changes that a human undergoes when he moves from one place to another, or even just sitting and standing. Now, what are the activities that we focused on when it came to recognizing? So these were the six activities that we chose: walking, walking upstairs, walking downstairs, sitting, standing, and laying. Now, in these six categories, these can be vastly categorized into two another categories being static and dynamic. Now, activity recognition. Who is this for? As I mentioned earlier, it is used for healthcare specifically. So, if that's the case, it is not for your common layman. It is for the people who have lost their cognitive abilities or the elderly who have difficulties in moving from one place to another, but then should also live independently. So that is the target audience. Now to the data set. Now, since we are in a lockdown and we couldn't really focus getting the sensors, etc., we have chosen an already made data set from UCI, and that is the human activity recognition using smartphone data sets. Now, how was this data obtained? A group of 30 people between the ages of 19 and 48 were taken as volunteers, and they performed the above six activities that I mentioned earlier. And these were used to predict the to monitor the acceleration and the change in the velocities while they perform these different activities at a particular frequency as mentioned here. Now, this was a 561 feature vector dataset. We have taken 9 parameters from them, and those were the accelerometer and gyroscope readings. Now, as far as the architecture for any activity recognition system is concerned, we have three main components. One being the data fetching module, which is the sensor data, which again has the basic monitoring of the different actions, and also the signal processing comes into it. And secondly, we have the feature processing module. Thirdly, we have a classification module. These two modules are where the machine learning and the artificial intelligence comes into play. Now, to our model. The model that we used was LSTM, as the data is rather sequential, as in the person could be walking for a while and then they could sit all of a sudden. So, LSTM seemed like a better fit to the problem statement, and hence we chose that. And we have used the latest version of Keras, which is 2.4.2 to be precise. And as far as the data set is considered, it had a lot of noisy values. So, as I mentioned earlier, LSTM seemed like a best fit. Now, how did we implement the model? We had 32 hidden layers using tan edge activation function and a dropout of zero point 0.5. We trained it over 30 epochs with a batch size of 16. And we used categorical cross entropy as the problem is a multi-class classification. And RMS prop seemed like the better optimizer and gave good results. As I mentioned earlier, we have used 9 parameters. Now, moving on to the challenges faced. When it came to the signal processing aspect of it, which the dataset already had mentioned, so they had used a sliding window protocol sort of a thing, which was basically overlapping two processes. The overlap rate was 50%. So we also noticed in the confusion matrix that there were few difficulties when it came to classifying similar classes. So that is what the interclass similarity and the intraclass variation is. For example, walking downstairs and walking upstairs were sometimes confused. Now, when it comes to the real world scenario, since I already mentioned, this dataset was obtained in an experimental setup and hence various environmental factors weren't considered. So, that is another viable challenge. And as far as data security is concerned, IoT devices and data security is an area under research. And as far as scalability and adaptability are concerned, this is the model that applies to web applications right now, And we have to further focus on integrating it with real time data and integrating it with apps and so on. Now we'll move on to the code and see the implementation and how we've done it. Now to the model. So as I mentioned earlier, we have used the HAR dataset, we've imported the required modules, and these are the 9 parameters that we use. So the body acceleration XYZ are the accelerometer readings in the XYZ axis, and when it comes to body gyro XYZ, that is the body gyroscope readings for the 3 different axes. Accelerometer monitors the speed and the change in direction, whereas gyroscope readings, they monitor the rotation. And the total acceleration of these two together is your XYZ. That is the total acceleration, the parameters. So these are the 9 parameters that we've used. And as far as the rest of the code is concerned, we have loaded the data using this code. And then we have the model for, and then we have the module for printing the confusion matrix. And this is where we have implemented the LSTM that I mentioned earlier. So as you can see, we have used a dropout of 0.5 and the 30 epochs and 32 hidden layers, categorical cross entropy, and RMS prop. So this was how the training was done. Now we implemented this using a Flask application, and now I'll show the code of that and execute it locally. Now this is the app.py file. We've imported the required modules. We've created a Flask instance, and we have loaded our model, which we converted into a model.h file. So we have rendered the home page, and this is where the predictions are taking place. So this gathers the input values from the user through the front end, and then this happens in the back end, and this is how the app runs. Now, as far as the home page is considered, we went for a rather basic template here, and I'll show it in a bit. So here we go. Now this is our home page for the app, and we enter the values in here, and as we give predict, we'll get the required outputs as sitting, standing, laying, or walking upstairs, or walking downstairs. So that's about the Flask application. Now moving on to the front end the web page. So as far as the web page is concerned, we have gone for a minimalistic design which has a soothing appeal, and we've chosen black and white because it had a good matte finish and it gave a good appeal when it came to the design. And as far as the tech stack is concerned, the web page was made using HTML and CSS. So the final thing that I would like to touch upon is the project prospects. So project prospects, as in what are the future implementations or additions that can be made to the project, or how exactly can it be used at a bigger sense. So that being, ambient assisted living is another great scope, which has great scope for research. So it is basically having smart environments that not only have sensors, but they also have visual surveillance, and these two can be integrated along with IoT and artificial intelligence. Together we get ambient intelligence, which is basically a smart environment, and continuously we monitor the person, and risk predictions can be made as such in real time. And finally, visual human activity recognition, which is basically, like I mentioned, using visual real-time videos or images to process what the person is doing, and in case if there are any accidents or something, the damage can be reversed as soon as possible, and the response can be mitigated quickly. Now, as far as the references are concerned, we used a research paper, and we found the same repo for the research paper, which is ST Archivare Lab, and they had implemented a deep convolutional LSTM model for the same. So it was a rather old model. So we took inspiration from the paper, and we implemented the recent version of it using Keras. The old one was implemented in Theano, so we implemented it using the recent version of Keras. And as I showed the model earlier, we got the So as I showed earlier, we have Keras here, and we got a good classification accuracy for the same as well, which was over 90%. And as far as our team is concerned, we have Ritik Bandari, we have Pratyaksh Bala, Akshat Anand, and myself, Gayatri. So that was it. Thank you.